Alright, question 4. The questions below refer to the function whose graph is shown below. All bold points have integer coordinates. Part A, determine the average rate of change of the function. So let's recall that the average rate of the function, rate of change of the function over this interval, -4 to -1. What is the average rate of change as a formula? It's very much related to the slope. It's the arc over, and we have to have an interval. So the arc over an interval AB is defined to be f of b minus f of a over b minus a. So in terms of our function, this is going to be f of -1 minus f of -4 over -1 minus a -4. So the denominator, -1 minus a -4, that's +4 minus 1, so that's 3. Then f of -1, so this is f, this is my function f, all of this. So f of -1, so here's -1, so that's f of -1, that's -2 minus, and then f of -4 is here, which is -3, so that's -2 minus a -3, which is equivalent to -2 plus 3, so that's 3 minus 2, so that's 1/3. So that's the arc over that interval, 1/3. All right, so what type of symmetry does the graph show? This graph is origin symmetric. And that means that it is an odd function. In other words, f of -x is equal to -f of x. Now, how did I know that so quickly just by looking at the picture? Well, if you remember origin symmetry, what makes a function origin symmetric, in addition to satisfying this requirement, is visually you can, if you flip it over this plane, and then you flip it over this plane, then the function will land on top of itself. And so that's exactly what happens here. So if you take this and rotate it here, you get that. And then if you rotate that down here, you get this portion of the function. And so that all adds up to being an origin symmetric function. Now I can prove that algebraically just by plotting some or doing some point calculations. So for example, say this point here, that's the point 2, 1. Now so 2, 1, what is f of -2? So f of -2 is right here, which is -1, and that's the same thing as -f of -f of 1. And because f of 1, oh, sorry, that's -f of 2, I'm sorry. And then because f of 2 is 1, and therefore that satisfies our condition here. So basically, to justify this type of symmetry, pick any point and then you just check and show that if you, let's say your point is A, and then check that f of -a is equal to -f of a. That's all I'm doing. All right, where is the function increasing? Okay, so the x value is where the function is increasing. So the function is increasing. Let me erase all of this. The function's increasing from here. Maybe I'll use a different color. We'll go red. So it's increasing from here to here and from here to here. So let's write down the intervals for that. So that's going to be -4 up to -2. That's here to here. Union 2 up to 4. And I did use parentheses there. So -4, -2, union 2, 4. And last part, D, what are the maximums? Okay, so the local maximums are going to be, those are the points, and that point is -2, -1, and I don't know why I circled this one. That is definitely not a maximum. That is a minimum. My bad. That's a minimum. I think I was in a hurry. So that's a minimum, not a maximum. Well, okay. What about maximums? So our maximums are going to be here and here. So actually, we have 3 maximums. That's a max. That's a max. And that's a max. So that point there is 1, 2. And this point is 4, 3. So 1, 2, and 4, 3 are my other maximums. Okay. Alright, I will pause the video and return to do questions 5 and beyond in the next video.